Okay, so let's look at lesson 6-1, understanding percent. In this lesson, we'll be able to represent and find the percent of a whole. Let's look at explain it. Tom made a vegetable pizza and a pepperoni pizza. He cut the vegetable pizza into 5 equal slices and the pepperoni pizza into 10 equal slices. Tom's friends ate 2 slices of vegetable pizza and 4 slices of pepperoni pizza. Okay, so there are shares of the pizza. That's the vegetable pizza. That's a pepperoni pizza. Let's see our questions. Part A, draw lines on each rectangle to represent the equal slices into which each pizza was cut. So how was the veggie pizza cut? It was cut into 5 equal slices. Okay. So let's draw 5 equal slices. That's about half. So I'm gonna cut somewhere over here. And then that's 1, 2. I'm sorry if it's not drawn equally. Yeah, so that's 1, 2, 3, 4, 5 slices. And then a pepperoni pizza. Into 10 equal slices. So we have the same thing except it's 10. So I'm going to start here and start with 5 equal slices first. And then I'm going to divide those 5 slices into halves. And that's gonna make us 10 slices, okay? So 5 slices and 10 slices. And then Tom's friends ate 2 slices of veggie pizza and 4 slices of pepperoni. So 2 slices of veggie, which is bigger than, which the slices are bigger than a slice of pepperoni pizza, right? And 4 slices of pepperoni pizza. So 1, 2, 3, and 4. Okay. So how can we represent this as a fraction and a ratio? Veggie pizza, 2 slices of veggie pizza out of 5 were eaten. And pepperoni, 4 slices out of 10 were eaten. Part B, Tom says his friends ate the same amount of veggie pizza as pepperoni pizza. How could that be true? How could you check if it's true? Is the amount of 2 slices of veggie pizza equal to the amount of 4 slices of pepperoni pizza? Is that true? How could we check? We could check by seeing if the fractions, the ratios are equivalent, right? So basically is 2.5 equal to 4 over 2 over 5 equal to 4 over 10 is the question. Well, can you verify that? You know, if you multiply both terms by the same number, you get an equivalent ratio. So you just have to figure out what number it's multiplied by. You multiply 2 by 2, 5 by 2 to get 4 over 10. And are they equivalent? Yes, they are equivalent. So how would you say that? They are equivalent ratios because 2 can be multiplied to both terms in 2 over 5 to get 4 over 10. Since the ratios that represent 12 that represent the slice, the amount of each pizza eaten are equivalent. His friends, we can say that his friends ate the same amount of vegetable pizza. Okay. There you go. What about focus on math practices? What if Tom's friends ate 6/10 of the pepperoni pizza instead of 4? How could you use rectangles above to find an equal amount of veggie pizza? So if pepperoni pizza was eaten 6 slices, how many slices would that be equivalent to veggie? Since you know the ratio of the slices now, if you eat 1 veggie pizza, that's equivalent to 2 slices of pepperoni pizza, right? So it's 1:2. The ratio is 1:2. You just have to make sure they stay the same. So if they ate 6 pepperoni pizza, what could be, how many slices do you have to eat for veggie? You divide 6 by 2 and you get 3 slices. So how could you use the rectangles? You can shade another 2 slices. And that's gonna be together 6/10. And you can shade another slice for veggie, and that's gonna represent 3/5. Okay, so the equivalent ratio for veggie would be 3/5 if they ate 6/10 pepperoni pizza. So let's summarize and write that down. You can shade 6/10 of the pepperoni pizza. And you can shade parts of the vegetable pizza until the shaded amount of the pizzas. Okay, that's how you can use the rectangles or the bar graphs. All right, so the essential question for this lesson is how can you represent a rate with 100 as a whole? Example 1, representing percents. What percent of people prefer bright white toothpaste? So we got a bright white toothpaste and just a regular toothpaste here. A percent is a rate in which the first term is compared to 100. Okay, that is the definition of a percent in this book. The percent is the number of hundreds that represents a part of the whole. So in this example, we see that 7/10 people prefer bright white toothpaste. So they, I guess, surveyed 10 people and 3 people chose the regular toothpaste. 7 people chose the bright white toothpaste. In total, they surveyed 10 people. So 3/10 and 7/10. Okay, so you can use the grid to represent the percent. If you have 100 blocks of grid, you can represent 70% by shading 70 blocks of them, right? Or another way, you can represent using the number line. So from 0 to 10 or 0 to 100, you can represent 70% or 7/10 on the number line. You just mark the 7 and 70. And the last way you can represent is by using equivalent fractions. 7/10, if you multiply that by 10 for both terms, you will get 70 out of 100, which is equivalent to 70%. So that's how you can represent percentages, okay? There are multiple ways to get to that idea. You can use the grid, you can use the number line, or you can use equivalent fractions to figure out the percentage. Let's look at try it. Jane won 9 out of 10 video games she played. What percent of the video games did Jane win? So 9 out of 10 is equivalent to how many percentage? So first, if you're gonna use equivalent ratios, you want to find out of 100, how many out of 100 is 9 out of 10? Or you can use the number line or the grid to figure out how many percent 9 over 10 is. So how many percent is 9 out of 10? 90%, right? All right, let's look at convince me. When using an equivalent fraction to find a percent, why do you write 100 as a denominator? So why do you need to get a number over hundreds when you're using the equivalent fraction ratio to get a percentage? Because what's the definition of the percent? A percent is a ratio with how much part you have out of compared to 100. That's the definition of the percent, right? So you always write the ratio with a denominator 100 because percent by definition is always out of 100. Okay, this is very important. All right, example 2 on the next page. Examine percents and wholes. Each line segment represents 100%, but the segments are not the same length. Use equivalent rates to find a percent or part of each line segment that points A and B represent. So point A lies on this number line where 2 inches represents 100%. Point B seems like it's on the same line, but not really. The line is longer and now 4 inches represent 100%. Okay, it's very important where your 100% is. So A is how much percent out of 100. 1 is half of 2, which means that's just half percent of 100. What's half percent of 100? 50%. But look at B. B is half of 100%. You see that? So 4 inches is your 100% now. If you only have 1 inch, well, how many percent is that for 4 inch? Right? It's not half, it's half of half. So 50 divided by half is 25%. That is 25%. C, 2 inches now would be 50%. D would be 75%. Okay, so depending on what your whole is, your part also changes. All right, so let's look at try number 1. Which point represents 50% on the second line segment? This is the second line segment. Where's the 50%? C, at 2 inches. Because, explain why. Point C is at 1/2 of the line segment and 1/2 and 1 inch is 2 inch is 1/2 of 4 inches, right? So 1/2 is equivalent to 50%. There you go. Example 3, use percents. You can use percent and mental math to find the length of a line segment. What if you just know a part and you don't know the whole, right? And you know the percent of the part. Can you figure out the whole? Yes, you can. Let's look at part A. If CD represents 10% and that's 4 inches, what's the length of line segment that is 100%? What is the whole thing, right? So if 4 inches is 10%, how many 10% do you need in 100%? You need 10 of 10% to get 100%, right? So that means you need 10 of this line segment, 4 inches. So we multiply 4 by 10 to get 40 inches. You see that? So it's always part out of the whole that makes the percentage, right? Your percent is 10%. Your part is 4 inches. So your whole, you don't know, right? So in order to get that, you can solve for the equivalent ratio by changing your percent into a ratio. 10% is 10 out of 100, right? So in order for 4 to be 10, you multiply by 2.5. Or from 10 to 4, you divide by 2.5. So 100 divided by 2.5 is 40 inches. So this is another way to solve it, but you can also use logical reasoning this way, okay? So this one, they used 4 inches as 10%, and they wanted to get into 100% on the denominator. So then 10 times 10 is 100%, 4 times 10 is 40 inches, okay? So you can use different ratios as long as you follow the rules of equivalent ratios. All right, part B, if EF represents 200%, what is the length of a line segment that is 100%? So from 200% to 100%, what do you need to do? In order for 200% to become 100%, you divide by 2. So you're going to divide 6 inches by 2 to get 100% in inches. 6 divided by 2 is 3 inches. So 100% would be 3 inches. So your part doesn't always have to be smaller than whole. If your part is bigger than whole, then you can find a whole, which is always 100%, by dividing your part. Okay? So let's look at try it down here. If CD represents 100%, what's the length of a line segment that is 25%? So your CD is 4 inches, right? CD is 4 inches. And if this is 100%, then what is 25%? So you can write another ratio saying 4 inches is 100% now. And I want to find 25%. How many inches would this be? So 100 to 25, what do you have to do? You divide by 4. So 4 divided by 4 is just simply 1, right? So 1 inch. Can you explain how you got this in words? 25% is 1/4 of 100%. So the length of the line segment is 1/4 of 4 inches. So it is 1 inch. There you go. All right, that was our lesson. Let's summarize our lesson. A percent is a rate that compares a part to a whole. The second term in the rate is always 100. So your denominator is always 100. The whole is 100%. Okay, that was lesson 6-1, understanding percent. We'll continue with the next lesson relating fractions, decimals, and percents in the next video. Thanks for watching, guys. See you in the next video. Bye. Ask Miss Kang if you have any questions.